Welcome to this explainer. Have you ever noticed that the business world almost never operates in a perfectly straight line? Think about it. If you double your prices, you don't just automatically double your profit forever. Unfortunately, our customers absolutely have a say in that. At a certain point, things start to bend, they shift, and eventually they fall. So today, we're going on a quest to really master these nonlinear realities. We're going to demystify a fundamental mathematical concept, the quadratic function, and show you exactly how it serves as the ultimate tool for finding that absolute perfect sweet spot to maximize your profit.
Here's our roadmap for today's journey. We'll start with the shape of business, then look at the anatomy of a parabola, followed by finding the vital points, real-world optimization, and finally, mastering quadratic functions. Let's jump right in.
Section 1. The shape of business beyond straight lines.
Okay, when we first learn about business or economics, it's incredibly tempting to just assume that more effort equals more reward, or that higher prices automatically equal higher revenue. But reality? Well, reality isn't a straight line. And this brings us to the ultimate dilemma every business owner or pricing strategist eventually faces. How do you find the exact price that actually maximizes your profit? If you sell a product and keep jacking up the price, sure, your revenue per unit goes up initially. Sounds great, right? But eventually, basic human behavior kicks in. The price gets way too steep, demand drops off, fewer people buy, and your overall profit starts to take a nosedive. Finding that perfect peak isn't just a guessing game, though. It's a mathematical certainty if you know what to look for.
When we compare a simple linear trend to a quadratic reality, it actually reveals a whole lot. A linear trend assumes this constant, almost magical growth, which, let's be honest, is entirely unrealistic to sustain indefinitely. Markets have limits. Resources have limits. A quadratic reality, on the other hand, embraces those peaks and valleys. It realistically models how variables actually interact in the real world, how they hit a maximum threshold and then decline. So to truly optimize a business, we have to ditch the straight line and embrace the curve.
Section 2. Anatomy of a parabola. The mathematical roller coaster. It really helps to think of our business metrics a bit like a roller coaster, climbing up the tracks to an absolute peak before gravity, something like market saturation or rising production costs, pulls them right back down. To understand this roller coaster, we need its blueprint, and that is the quadratic function. It's a nonlinear function written out algebraically as f of x equals ax squared plus bx plus c. There's really just one strict rule here. A absolutely cannot be 0. Why? Because that little squared attached to the x is the literal hero of our story. That exponent of 2 is exactly what gives this function its distinct sweeping curve, rather than just being another boring straight line. Now, when we take that algebraic formula and map it onto a graph, it translates perfectly into this visual shape, the classic parabola. This smooth, beautifully symmetrical curve is the direct visual representation of our quadratic equation. Every single point you see on this curve corresponds to a specific combination of x and y from our formula. So suddenly, all that abstract algebra becomes a very tangible, easy-to-understand geometric shape. What's really interesting here is how just one single, tiny piece of our formula completely controls the entire orientation of the shape. Look at the variable a. If a is a positive number, our parabola opens upward, forming a kind of U shape. This is incredibly useful if you're trying to find the absolute minimum of something, like, say, your production costs. But if a is a negative number, the parabola opens downward, creating an arch or an N shape. And this is exactly the curve we want when we're trying to find the absolute maximum of something, like our total revenue or our overall profit.
Section 3. Finding the vital points. Navigating the curve.
So, now that we know what the curve looks like, we need to actually navigate it by identifying its anatomical markers. And without a doubt, the single most important marker on this curve is the vertex. The vertex is the absolute turning point of the parabola. If your curve opens downward, the vertex is your absolute peak, the highest possible y value you can hit. If you're charting profit, the vertex is exactly where you want to be. It is literally the mathematical sweet spot where you are making the maximum amount of money before that curve inevitably starts sloping downwards again. Fortunately, finding this sweet spot doesn't require any guesswork. It's actually a super simple logical procedure. Step 1. You just pull the numbers for A, B, and C right out of your quadratic equation. Step 2. To find the optimal horizontal position, say your absolute ideal selling price, you simply plug those numbers into a tiny formula. X equals negative B divided by 2 times A. Then, step 3, once you have that perfect X price, you just plug it back into your original equation to find Y, which reveals your maximum possible profit.
But the vertex isn't the only vital point we care about. We also have to look really closely at where our curve crosses the horizontal axis. These points are called the x-intercepts, or the roots. And in a business context, these points are incredibly meaningful. Because the height of the curve right here is exactly 0, these intercepts represent the exact moments your business breaks even. It's the literal crossover where your profit goes from negative to positive, or sadly, if you've pushed your prices way too high, from positive straight back down to 0.
So let's quickly anchor this learning by recapping a quadratic function and their characteristic components. First, we have the vertex, which is your ultimate target for maximum profit or minimum cost. Then, we have the axis of symmetry, which is an invisible vertical line running straight through the vertex, perfectly mirroring the left and right sides of your business cycle. Next are the roots, which act as your absolutely critical break-even milestones. And finally, the y-intercept. This represents your starting position. Think of it like your initial sunk cost before you've even managed to sell a single unit, back when X is exactly 0. Together, these components make up the complete anatomy of our model.
Section 4. Real-world optimization. Math meets money.
All right, so how do we actually turn these abstract mathematical terms into a real-world strategy? Take a look at this downward opening parabola. This isn't just some arbitrary doodle. This is a highly precise representation of a real-world profit function. You can clearly see the profit rising as the price increases on the left side, hitting that ultimate glorious peak at the top, and then plummeting on the right side as the market firmly rejects the overly high price. By mathematically pinpointing the vertex on this specific curve, we completely remove all the emotion, all the guesswork from our business strategy. We just know the exact maximum profit point.
I really want to ensure you never forget this little fraction right here, negative b over 2a. This simple calculation is literally the magical key to unlocking that peak. Whether X represents the thousands of units you need to manufacture or the exact dollar amount you need to charge your customers, this tiny fraction guarantees that you will land perfectly on the vertex of your specific market's parabola.
Section 5. Mastering quadratic functions, the big picture.
We've moved from a simple squared variable all the way to a robust system of financial optimization, and this visual brilliantly illustrates our entire journey today. When you model complex, messy, real-world data and fit a quadratic curve to it, suddenly everything makes sense. You can visually identify your starting costs, you know exactly where your break-even routes are, and most importantly, you have these laser-guided coordinates pointing directly to your maximum potential. Mastering this formula truly transforms what might look like intimidating algebra into a massively powerful, highly practical toolkit for success.
We've seen just how effectively the parabola handles the push and pull of pricing and profit. But math doesn't just stop at the cash register. Everything from the trajectory of a thrown object to the optimization of fuel consumption relies on these exact same characteristic components. So I'll leave you with this final thought. If a simple mathematical curve can reliably reveal the absolute peak of your profit, what other invisible patterns in your life and work are just waiting to be modeled? Think about it and keep exploring the curves around you.